Good afternoon, gentlemen. Let's talk a little bit more about that old computer KVM thing that the video just posted for today. And I guess I'll go ahead and post this one on YouTube at the same time as Odyssey, just cause. But the stuff usually appears on Odyssey before it does on YouTube by a week, so you can go there if you want that stuff earlier and stuff. And there's a shitty Discord server that you can join if you want to. It's well, you know how Discord servers are. Yeah. Come and we can talk about old computers, maybe. Anyhow, before talking about the old computer KVM thing, I'd just gotten those Wi-Fi modules, and I guess I kind of had like Wi-Fi module on the brain, because I thought about just making something for keyboards, for keyboard input, you know, but then I got all like thinking about other stuff and things. But in any case, I digress. I changed my mind a little bit about what I think the best way to do this would be, because I found out that on the Raspberry Pi Zero and on the Raspberry Pi 4, but I don't think on the 2 or 3 or the original Raspberry Pi, because they don't have the right chipset. But apparently the port that power is normally applied over, the USB-C port on the Raspberry Pi 4, and the non-power port, I think, on the Raspberry Pi Zero, you can configure them as either USB Ethernet gadgets or USB human interface device gadgets. So it's possible to make one port of certain Raspberry Pis. I'll be using a Raspberry Pi 4, I think, for reasons that I will explain in a bit, as to emulate a USB keyboard. And that obviates the need to use one of those Arduino Leonardo clones, and it moves a lot of the software onto a more capable platform with a little more capable development environment. Because the Raspberry Pi also has that shitload of GPIO pins, and I think, especially if it was running a real-time kernel. You could probably do it even without a real-time kernel, but I think definitely with a real-time kernel it would be possible to bit bang the PS2 protocols and the ADB protocols over the GPIO ports, because I mean that thing's several orders of magnitude faster than that ATmega 32U2 or whatever it is that's on that Pro Micro Arduino clone. Let's draw some pictures. Pictures are good for my small brain, because my brain is small. So imagine we've got a Raspberry Pi. I'll make it great big, because I'll have to have lots of wires coming out of it. So we've got our Raspberry Pi, and we plug a keyboard into one of its regular USB ports. Alright, and then over the GPIO port, we've got our one USB-C port, and we configure that to act as a USB HID gadget. And there are two data lines on a USB port. There are two data lines, 5-volt power line and a ground. When we're switching this between things, we only need to switch those two data lines, right? So that's why I've only got 2 wires coming off of this USB port. So this will be like keyboard, USB keyboard, and we'll call that the USB keyboard bus, and it'll go into like it'll go into this like hat all right, there will be this hat that goes on top of the Raspberry Pi that implements some of the stuff that I'm going to draw here. And then on top of that hat, it'll have its own headers on it that'll break these buses out, right? And then for each device that you want to put on the KVM, you'll add a hat on top of that, and they'll all use like those long headers, you know, that you can they'll stack on top of each other. You know what I'm saying? So you'd screw them together with like standoffs to space the boards out, and just keep plugging boards in, and you'd have this wide thing, and there'd be like a module for each computer that was supposed to be attached to the KVM, or you know, you could have one module that you know, outputted like several different like whatever you could fit in. You know, you could have one that did like two different regular like VGA plus USB computers or something like that. You wouldn't have to have one module for each machine, but like we want the configurability of like being able to stack different types of modules together on the thing. So we'll have like a module to connect to like a more modern PC with USB keyboard and mouse ports and like a VGA monitor, and we'd have a module for connecting to like VGA plus PS2 keyboard and mouse, right? We'd have a module for connecting to, say for example, like CGA with an XT keyboard and a serial mouse, you know what I'm saying? Or a module to connect to Macintosh ADB plus Macintosh RGB, or Apple IIgs plus 15 kilohertz RGB, or whatever, you know what I'm saying? We'd just stack these modules depending on what types of machines we wanted to attach to the KVM, and the PC boards for these modules could be kept fairly small, you know, like the size of the Raspberry Pi or smaller. So they would be very inexpensive to produce at these PC board fab houses like JLC PCB or something like that. So that would keep the costs pretty low, even though there are multiple boards, you know, like you could get, especially if you ordered like several boards at a time, you could get them, you know, for like $2 a piece or something probably, and then you just have to populate them. I mean, yeah, this will end up being more expensive than just like a boring ass regular like KVM like you get at like Staples or something like that, but the ability to like use multiple types of protocols with it, I think, is the killer app, you know what I'm saying? So anyway, I digress. So this will be the USB keyboard bus, and it'll come out onto this bus on top of this hat, right? And then we'll take some of the GPIO ports, and we'll implement PS2 keyboard and PS2 mouse lines, and once again there's a data on a clock line for each of those, so there will be 4 lines, 4 GPIO lines for that, and the Raspberry Pi has some of the GPIO pins can be configured to be a serial port. I need to read up on some of the serial mouse protocols. I haven't researched that yet, but I assume, well, okay, I'm not sure, because my recollection is back in the day when I was using serial mice on DOS machines, the mouse had to be plugged in when the mouse driver was loaded in AutoExec, otherwise it couldn't detect that the mouse was there. So we may have to do some funny business once again, probably with like, well, I don't know, one of those ESP01 modules could do it, because they've got like a bidirectional serial port and 2 GPIO ports, so you could have like a serial mouse protocol out and take a PS2 mouse protocol in, so it could probably attach to this PS2 bus with a $3 thing and go into a serial port, assuming that it doesn't have to use like hardware flow control. I don't think it does, because the way those serial mice worked without their own power supply, because I mean there's no power supplied over RS-232 ports, yet you could plug a mouse in and it would just work, right? I think they forced a lot of the hardware handshaking lines on the serial port high, and used that. I mean, you couldn't supply very much power with that, but it was enough to power the mouse. The photo, I guess they used like, yeah, photodiodes and a wheel with holes in it, and whatever miscellaneous little microcontroller circuitry was in there to turn that into a serial signal. You know what I'm saying? So anyway, that's a bridge that we can fall off of when we come to it, I suppose. And notice that there is no USB mouse bus here. I think that this USB HID gadget, I think it can only act as one thing at a time. I don't think you can configure it to be a keyboard and a mouse, but I need to read up a little bit on that too. So we'll actually switch a legitimate mouse on and off of the we'll have a mouse here, USB mouse, and it'll actually like legit just be just go straight onto this bus. It'll be powered, you know, by the same 5-volt source as everything else, but it'll just go legitimately straight into this bus. And then we'll have one of our switching chips, some kind of analog multiplexer IC. Probably I need to do it. I think that the chips that I've got are switch fast enough to switch USB stuff, but I'll have to check. So we'll put one of those switch chips in here, and we'll just feed this mouse back into a USB port on the Raspberry Pi, so that when one of these modules that plugs into this hat it requires like a PS2 mouse signal on these lines here, it'll close this analog switch here, and read the serial mouse data off of this mouse, and then translate it into PS2 mouse data, which it'll send back out over this to whichever module is looking for it. And then we'll also have to have, this should handle all of the keyboard and mouse input to the modules, and then we'll just stack modules on this bus, and they'll tie into these lines. Like say we have one that needs just only a PS2/AT keyboard, it'll just hit these two lines, right? It'll piggyback right onto them, and it'll have its own analog switch IC here, and those will all be selected by using like a 3-to-8 decoder chip. I think it's it's not a 74 LS86. That's a 4-bit adder. Crap, I can't remember off the top of my head. Anyway, it doesn't matter. The 3-to-8 decoder takes like a 3-digit binary number and selects one of 8 output lines. So we'll have like 8 output lines going to these things, and then the bus will like fall off of the end, and you'll be able to plug in another board on top of that'll decode some further address bits, probably using the aforementioned. You could use a 4-bit adder for that, and then you'd have 7 bits of device selection, which would be enough for 127 devices, more than you'd want to stack onto this thing anyway. You'd just hardwire one side of it to decrement decrement the number each time you stacked one of those 8 more things boards on top of it, and right. Anyway, that would take some more I/O ports. We'll just put 3 here for now. That'll come out into 8 lines. That'll go onto the bus. So what'll happen is it'll put a number on part of the GPIO port here to select which computer it wants to hook the keyboard and the monitor, which we'll talk about here in a second too. So one of these lines will then will go low, and that'll select which of these modules. This picture is getting messy. Alright, so one of these modules will connect to this line. And we can probably do a little bit of funny business on the modules where they Yeah, we might be able to do something so that the modules automatically number themselves as they stack. But no, we don't want to do that, because then if you removed a module or added one in the middle somewhere, you'd have to reconfigure all the software, and that would be a pain in the ass. We'll have like jumpers or something on the module to select what its ID is. Anyway, so the Raspberry Pi will be like, I want to select this module, like module number 4 or something like that. Alright, and so the module will get this low signal that says it needs to be selected, and in response, it'll have these analog switches attached to it that is connected to this bus, and it will assert a signal saying, yes, I want this switch to be activated, right? So then it'll be able to pull this PS2 keyboard information off of this bus and feed it into the old computer, right? And so at the same time that, this line is selected, the software that's running on the Pi will have to be configured to, turn this switch on too, so it'll be able to select, like which, so it can read that mouse and actually write the mouse data onto the PS2 mouse part of the bus here, right? So, clear as mud so far. All right, let's talk about the video bus. So, we'd probably want to be able to display the Raspberry Pi's video. Like we could call it like module 0. It would be its own like module 0, right? We'd want it to be able to display its own video, so you could like configure it directly using the keyboard. You know what I'm saying? That would be handy. So we'd have to plug in like an HDMI to VGA module just to get VGA output, because that's going to be our video standard. And then we'll have this this video bus, all right, and it'll have a number of signals on it, and this thing will go onto the video bus through another matrix of these analog switch ICs. I may have to use an actual video switch IC, which is a little bit more expensive, but the regular like 74LS series, or maybe it's a 74HC series part, like the 2048 or something like that. I can't remember off the top of my head, but I think those are fast enough to do like 31.5 kilohertz VGA. But once the pixel clock gets much higher than that, then you have to use an actual video switch chip, which costs 3 or 4 times more, and pardon me, as far as I know, is only available as a surface mount device. But you can get them in SOIC packages, so they won't be that hard to solder. So it'll still be like stuff that you can do at home, you know what I'm saying? So we'll have our video bus, and it's actually a number of lines, but I'm going to just draw it as one here. Because, for simplicity's sake. Alright, so this thing will tie into the video bus here. And then when module 4 is selected, there'll be like another, the video output of the old computer. Video VGA output of the old computer. This module will assert the same line that's asserted to turn on this thing, so it can read off of the PS2 and write to this PS2 keyboard part of the bus here. It'll also assert this analog switch down here that'll tie this old computer's VGA output directly onto this video bus. And it doesn't have to be VGA. It can be, we'll have some other lines in there. It'll take 10 lines, I think, altogether, if I've thought this through right. We'll be able to support digital RGBI. Oh, I didn't take EGA into account, but we can do that. We could do that on the module itself. It's not like there are that many EGA machines out there anyway. There are a lot of CGA machines, a lot of VGA machines, but there aren't very many EGA machines. Anyway, I digress. Well, yeah, we can change this if we have to. This is just initial napkin scribbling. I should have thought this through more before recording this. Anyway, so where was I? Yeah, so the VGA signal will be tied onto this video bus. Of course, since everything's decoded through this 3 to 8 decoder here, only one of these can be selected at a time, so that'll automatically like deassert any of these other switches that are connected to this bus. So only one module, only one old computer will be connected to the VGA part of this video bus at a time. And then we'll have more of these switches down here coming off of a video bus. We'll have like a switch that can just directly route it to the VGA output, right? We'll call this and that'll go to the monitor that we're looking at with our eyeballs, right? Here's a monitor with some porn on it, because, you know. All right. So, and then we'll also have there will be a line for composite and lines for S-video on this bus. So we can also like have a pair of switches. We can have like a composite to VGA converter, like one of those like off-the-shelf ones, you know, that just plugs in to this stuff. And we can have a couple more of those switches that can either throw it in or out of this. Like if we turn off this switch and turn off these two, then the composite signal that's coming out of the old computer and being gated onto this video bus will go into this composite to VGA converter and put out onto the lines that go out to the monitor, right? And likewise, we can do the same with a GBS 8200 over here for analog RGB signals in the 15 kilohertz range, like for the 2GS and the Amiga and stuff like that. Now, I have no idea how Amiga keyboards work, so that's something somebody else will have to do. I don't have an Amiga, so sorry guys, but we can figure it out. I've been meaning to get like a shitty 2000 to fix up or something anyway, so maybe one of these days I will. Anyway, so we'd have a GBS 8200 here, scan converter, one of those China specials, you know what I'm talking about. And we could also have a CGA to RGB converter on here. I made some videos about that. I didn't draw this very well. And we can have like a two-way analog switch between them here. This is up here. Don't pay attention to that. Like a two-way analog switch, so we can bypass this CGA to RGB thing here, so we can turn it on and off. If we're trying to get like a TTL RGB signal through the GBS 8200 and out to VGA, or we can get it out of there if we're just trying to put like an analog VGA signal off of this bus. An analog RGB signal straight off of this bus through the GBS 8200, getting scan converted up to 31.5 kilohertz so that it'll display on a regular monitor, and then out to the monitor, right? So the lines that we would need to implement this, I think some of these lines are digital and some of them are analog, and the analog lines, which include both signals in S-video, I think are 1 volt peak to peak. I think composite video is 1 volt peak to peak, and the RGB signals in analog RGB and VGA are, well, it depends on who you ask. Some people will tell you it's 0.7 volts peak to peak, and some sources say that it's also 1 volt peak to peak. So whatever. They're way less than 5 volts anyway. And we don't want any of these devices down here, like the GBS 8200 or the composite to VGA adapter, that are designed to take these 1 volt peak to peak signals. We don't want to accidentally gate like a 5 volt digital RGB signal into the inputs of those devices, because we might damage them. Which would be very unfortunate. So unfortunately, that means that we have to have a bunch of extra lines on this video bus, I think. We have to have all of our digital lines will be, we'll have a digital RGBI will be a digital red, green, blue, digital intensity. Now this, I didn't even think about EGA in this. EGA has 6 RGB lines: red 0 and red 1, green 0 and 1, and blue 0 and 1. So it can actually display 64 different colors. The monitor, the video format is capable of displaying 64 different colors at the same time, although the video cards, the EGA video card, was only capable of displaying 16 of those at a time. But it has a palette of 64 colors, and the monitors can actually display all 64 at the same time if you had a video card that supported that. But I digress. So there's an intensity signal that's digital, and the horizontal and vertical synchronization signals on VGA are both digital signals. Now it turns out that I did a little research on this. It turns out that the composite sync signal on analog RGB is actually also supposedly a 1 volt peak-to-peak signal, although I was generating a 5 volt signal with that GBS 8200 back in those old videos, and feeding it straight into a VGA monitor, and that seemed to be working fine. It's still a square wave, whether it's 1 volt peak to peak or 5 volts peak to peak. So maybe I was just overdriving the monitor, but since it's a square wave, it didn't care. You know what I'm saying? If it was like edge detecting, even if it was way over voltage, maybe it was fine. I don't know. So those are our digital signals anyway, and then we also have these are digital signals, and we also have some analog signals, the ones that are either between 0.7 volts or 1 volt peak to peak, and that would be the R, G, and B signals from VGA and analog RGB, and also that composite sync signal from analog RGB. So there's a minimum of 4 of those lines that we need. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 10 lines that we would need on this video bus, and it would actually be 12 lines if we wanted to support EGA. So let's just say 12, and I'll have to redesign this later in my head and brain. Although, yeah, we can share the intensity pin with like red 1 or something like that, because EGA doesn't use the intensity pin. And we can just leave out like red and blue. We can use green for the video signal for MDA and convert it in the same way with CGA to RGB converters. Anyway, so we can share some of these analog lines too, I think. The Y and C signals for composite video, because we won't be using RGB video and like S video at the same time, so we can share these lines, you know what I'm saying? Like, I think, yeah, because we shouldn't be able to gate stuff onto it at the same time, and even if we do, since these are all lower voltage signals, it's not like they're going to go into the input of something and damage it because the voltage are too high. So I think that'll be fine. But anyway, we'll also have to have a composite video signal. We can put it on green. So we can share these lines and not have to have like 3 extra lines here. Because the more lines we have, the more the lines will interfere with each other, I'm afraid. And when we make the PC boards for these modules, I mean, I'll prototype the shit on like breadboards and stuff first, but that'll be pretty electrically noisy, especially at VGA frequencies. So the video quality will probably suck big time. But like when we make boards to do this, like actual honest to god like manufactured PC boards, I think they'll have to be like a 3-layer board or maybe a 4-layer board if we need to have traces that cross each other. Hopefully we can go with 3 because that's cheaper, but we'll put all the actual traces for these modules and for this all this stuff. They'll go like in the center of the board, and then we'll have like a ground plane and a 5 volt plane on either side, and that should help. Well, I don't know, that might cause like capacitive coupling. I don't know, maybe it should be 2 ground planes instead. The standard practice is to use a ground plane and a VCC plane, but on the inner layers, and put the actual circuit traces on the outsides of the board. But I think if we put the circuit traces on the inside of the board and have a couple of like ground planes on top of that, on the outside of the board. That'll help keep things shielded a little better and keep our video signals from getting all shitty with all of this stacking and stuff like that. And maybe maybe the stacking's not the best idea either anyway. I don't know. I'm just a hick living in a shack with some old computers. I'm not smart enough to know about all of that high frequency analog stuff. So if you guys have any better suggestions as to how to make this work right, I'd love to hear them. But in any case, so this does away with all of those little Wi-Fi modules. It would be hard cabling everywhere, which may be a pain in the ass if you've got like stuff that's far away that you need to hook stuff to. But well, you'd have had to have done it with the video anyway, even if the keyboard and mouse signals were going to be carried over Wi-Fi in our previous design thoughts thing. So it'll just be a Raspberry Pi, probably a 4, because you know, that'll give us enough USB ports to do stuff with. And with a Raspberry Pi 4, we can boot it up like straight into like an instance of like Cool Retro Term or something that's running like our configuration software and stuff. And there are several pins on the 40-pin Raspberry Pi header that can be configured as serial ports as well. I think there are, 5 or 6 of them? I can't remember for sure. Maybe there aren't that many. Maybe I'm full of shit. Pardon me. But in any case, that would also allow us to use this thing as like a serial terminal for connecting to old Unix machines and stuff that don't really have keyboard inputs and video outputs per se, just RS-232 ports. We'd have these 6 USB ports on the Raspberry Pi header, and if we needed more than that, it's got like regular USB ports, so we could also plug those FDTI USB serial dongles in and use them as well. Of course, we'd need RS-232 level converters on those pins. So, you know, yeah. So you could the software running on the machine could connect to those machines over the serial port using like Cool Retro Term as the front end. So you'd have like that CRT emulation on your LCD if you wanted it, and it'd be kind of like groovy, man, and shit, right? So anyway, those are my revised thoughts on a KVM thing for a diversity of old computers. That looks a little more complicated, but most of the complicated part of it would have been just as complicated the other way. So and I think this is a little more changing the software, since this is be running an honest-to-God operating system and have like internet access if you want it. I think changing and updating the software on the thing and the configuration will be far, far easier doing it this way than the way we were thinking about doing earlier with all the little Wi-Fi modules and all that shit. Alright, thanks for joining me. Clear as mud, I hope. Let me know if you have any ideas that would improve this situation. And I'll talk to you next time. See you later, bye.